Welcome students. Today in this class I am going to discuss how to design a gazetted base which comes under unit 4 compression member, and the subject code is CE8601 design of steel structures. Let's say example, design a gusseted base to carry a factored axial load of 2800 kilonewton. The column consists of ISHB 450 at 0.855 kilonewton per meter with two cover plates 250 into 20 mm on either side. Take the effective height of column as 4 meter. So what is given is you have to design a gusseted base, and the factored axial load is given as 2800 kilonewton. The column consists of ISHB 450 at 0.55 kilonewton per meter, and two cover plates are there, that is 250 into size 250 into 20 mm, and the effective height of the column is 4 meter. These are the things given in your problem, and what you have to do is you have to design a gusseted base. So step 2, the first step 1 is your given data, and step 2 is assume M20 grade. We have to assume the M20 grade concrete. So strength of the concrete pedestal is 0.45 FCK. This is 0.45 into 20. 20 is nothing but this 20. FCK is the compressive strength of the concrete. Therefore, this 20 is your compressive strength of the concrete. Therefore, 0.45 into 20. Now calculate the area. Area is equal to this load by this strength. That is, load is given as 2800 kilonewton. Therefore, 2800 into, to convert kilonewton into newton, 10 power 3, that is 10 power 3 divided by 0.45 into FCK. FCK is 20. Therefore, area is equal to 311,333 mm square. Now select, this is your area. Now for this area from steel table, select the ISA, that is rolled steel section angle. That is ISA 150 into 115 into 15 mm angle, and 16 mm thick gusseted plate is selected from the steel table. For this area only we are selecting the ISA, that is 150 into 115 into 15 mm angle and 16 mm thick gusset plate. So minimum width required is equal to this 450 plus this 2 into 20, because this cover plate is 20. Therefore 2 into thickness of 2 into 20 plus 2 into gusseted plate. This thickness is 16 mm. That is 2 into 16 plus 2 into 115. So if you calculate 450 means this 450 ISHB 450 plus this 2 into this thickness 20 plus 2 into 16 plus 2 into 115. So if you calculate, you get the answer 752 mm is approximately equal to 800 mm. Therefore, minimum width required is equal to 800 mm. Provide 800 mm width or wide plate. Provide 800 mm width or 800 mm wide plate. Now calculate the length of the base plate. Length of the base plate is equal to this area by width, because area is equal to length into breadth. So if want to calculate length, area by breadth, therefore is equal to this area. Area is 31111 divided by with 800. Therefore we get 389 mm is approximately equal to 500 mm. Provide 800 into this width into length 800 into 500 mm base plate. So now actual upward pressure is equal to force by area. So what is the force? 2800 kilonewton. 2800 into 10 power 3 divided by 800 into 500 is equal to 7 Newton per mm square. So now provide the upward pressure in the in lies way, that is A, C and B upward pressure is 7 Newton per mm square. Therefore, this length is calculated by this 450 gusseted plate with 450 divided by 2 plus cover plate 20 plus 16 gusseted plate thickness plus angle 15 angle thickness 15 by 2. We get 260.5 mm. This is your diagram. 450 is 20 mm cover plate. This is 16. This is 15. So this from that only we calculate 450 divided by 2 plus 20 plus 16 plus 15 divided by 2 is equal to 260.5 mm. Now total load per mm strip is equal to this 800, this load, this length 800 into this load 7. You get total load 800 into 7 is the total load per mm strip. Reaction at RA is equal to 800 into 7 divided by 2. We get 2800 Newton per mm. Maximum bending moment at center is equal to this 800 into 260.5 minus 7 into it is 400. This here 800. So divide by 2, get 400 into 400 divided by 2. So half the load, maximum at center. So half the load, that is 800 divided by 2 equal to 400. 400 into 400 divided by 2 is equal to 169,400 Newton mm. This is your maximum bending moment at center. So maximum bending moment is 169,400 Newton mm. Now the bending stress is equal to Fy divided by gamma m naught. Fy is 250 and gamma m naught is 1.1. Therefore we get bending stress is equal to 227.27 Newton per mm square. Now moment, equate this moment is equal to F into Z. This F is this value, bending stress value, and this is the section modulus. M is the bending moment. What is M? 169,400 Newton mm. Therefore, 169,400 is equal to, what is F? 227.27 into this BD square by 6. So we take with us 1000 mm. That is 1 into T square divided by 6. That is the section modulus is mostly BD square by 6. For that, take with us 1 meter. Assume this 1 into 2T square by 6. Therefore, we get thickness is equal to 66.87. So this approximately is equal to 67 mm. Provide 70 mm thickness base plate with 800 into 500 mm. So we provide 70 mm thickness base plate for this 800 into 500 mm. So this is length, this is breadth. Now the thickness is 70 mm for base plate. The length is 800 mm, base width is 500 mm, and the thickness is 70 mm. Now how to provide the connection? So between gusset plate and column, the connection is done for the 50% of the axial load. So we are connecting the gusset plate and column. So for which load we have to consider is, we have to consider 50% of the axial load. Therefore, design load for 2 gusset plate at 50% of total load. For 2 gusset plate at 50% of total load is 50 by 100 into this load 2800. So therefore we get 1400 kilonewton. So this load on each plate is equal to 1400 divided by 2. Divided by 2 is equal to 700 kilonewton. Using 22 mm dia plate. So load on each plate is equal to, this is 1400 kilonewton. 1400 by D is equal to 700 kilonewton. Using 22 mm for 2 gusset plate only, this is 1400, because design load for 2 gusset plate at 50% of total load. So for each plate it is, we have to divide by 2 means 700 kilonewton. Using 22 dia bolts, the strength of 1 bolt is equal to 0.78 into pi by 4 into this value, this dia value 22 square into this 400, strength is 400 divided by root 3 into 1 by 1.25. This is a formula. 400 divided by root 3 into 1 by 1.25. This is your this is the formula from your code book. So 5 by 4 into for this dia answer you have to put. So therefore 54753 Newton is your volt value. Now what you have to find is you have to find the number of bolts. So number of bolts required for the connection of the gusset plate to the column. So number of bolts is equal to what is the load on each plate 700 into 10 power 3. That is is in kilonewton. So for converting into Newton, we put 10 power 3. Divided by strength of bolt. That is the load by strength. So load by strength will give the number of bolts. 54753 will use strength of the 1 bolt. Is equal to 12.78. So therefore, provide 60 numbers of bolt for the connecting the column to the gusset plate. So this is the way you have to design your gusset base. Thank you.